Okay, we got it the second time. Persistence pays off. I just proved it. All right, so example 4. This kind of is similarly to what we're doing in 1.3, simplifying. We're just working primarily here with exponents. So simplify the following expressions without a calculator and without sweating, right? Got some rain last night, so it's relatively cooler. This classroom, most people think, is also kind of cold, and I have a fan, so we shouldn't be sweating, right? It's one of the warmer ones? Yeah, I know. I wish I had a colder classroom, but oh well. Okay, so what does it mean to simplify this expression? Have fewer things at the end, right? Fewer symbols, fewer numbers, fewer letters, fewer exponents, all that good stuff. How many terms do you see? 1. Very good. 1 term. Well, we have 2 main factor groups, okay? Because they're all multiplied together. So what we're going to do as we go down, remember, everything has to be equivalent to above and below. We're going to kind of work on each factor group and see if we can't do something in each one. All right, so the first thing, we have 3 factors raised to a power. I'm going to help myself. I'm going to give little exponents there because I know the rule says that I can distribute the exponent to the other exponents, not to the numbers themselves. So I end up with 2 to the second power, which at this point, if you want to call it 4, that's fine. And then it's a to the second power, b to the what power? 6, okay? And as I do that, I could drop the parentheses. That's kind of what we're trying to do. If you can tear down the walls, you can eventually get people together, right? Like East and West Berlin. Times, here, I got a 5. There's nothing on the outside there except the 1, so I'll just rewrite the 5. But now I have a quantity under a square root, right? So what did we do last week? Anytime we saw a radical, we knew that we could write that entire blob as a fractional exponent. So this is going to be the quantity, ab to the 5th, to the what power? Not second. You telling me squaring something's the same as square rooting it? It's a 1/2, right? Remember the little, did I draw the picture of the flower in the underground? You remember that? I thought that would be like something that would help y'all never forget to remember. Yeah, where roots are found underground, right? And so the root index, there it is. The roots are found in the denominator. The roots are found in the denominator of the fraction, okay? So don't make that mistake. All right, so there we go. Now I've gotten rid of the radical at least. So as I go down to the next line, I'll look to see if I can combine anything. I have a 2 squared times a 5. Those are both of the same type of factors. So what is 4 times 5? 20. So I'll just write down a 20. And I still have the a squared b to the 6th. And now I can get rid of the last set of parentheses. If you want to put a little 1 there, to help yourself, we now distribute the exponent. So that becomes a to the 1/2 and b to the 5/2. Remember, we're multiplying there, and you multiply straight across. Now, here's what I would offer, especially in the next problem as we do this together. You should be able to go from there to there. Okay? That would save a whole line of writing. If you have the square root of multiple factors, each of those factors is just going to get that 1/2 or the 2 in the denominator as you write it down. So you can say it's a to the 1st, oh, 1/2, b to the 5th, oh, 5/2, and save that middle step, okay? But remember, it's better to show a step than not show a step, especially in the early stages when you're learning how to do things, okay? And really, we don't need to write those lines, but it's okay to have them. Okay, so now we have all of our parentheses gone. These are all implied multiplied together, so we can combine them in any order. We typically put numbers first, and then all the variables in alphabetical order. So 20 is already a 20. I'm going to have 1 factor of a and 1 factor of b. So even though a squared and a to the 1/2 are not written side by side, I can combine them by doing what with their exponents? Adding them, right? Multiplication becomes addition. So quickly in your head, what's 2 plus 1/2? 2.5. Yeah, it's 2.5. But you know what? That's a mixed number. We don't use mixed numbers. That's for little school. Some of you all might say 2.5. Ooh, yucky, yucky, gross, gross. It's a decimal. That's like calculator language. So we like to write them as fractions, improper fractions. So here's what you would do. Like in little school, remember they told you how to convert your mixed number? They say you take the big number and you multiply to that and then you add that, right? It's the same thing. Here's what you want to tell yourself. You're going to have 2 plus 1/2. If you have a whole number and a fraction, just say, oh, I need to multiply that whole number by the denominator over itself. So 2 is actually how many halves? 2 is 4 halves, right? So 4 halves plus the 1 half gives you 5 halves. Right? And you could do that quickly in your head. Just say, 2 times 2 is 4, plus 1 is 5. Good morning. Happy Monday, Tuesday. Ish, right? 5 halves. And then b to the what? 6 plus 5 halves. Let's do this one without going off to the side. 6 is how many halves? 12. Good. So 12 halves plus 5 halves? 17 halves. See, there you go. You don't need calculators. Y'all are the calculators. Sweet. All right, so we're almost done. We have one representative numeric factor, one representative A factor, and one representative B factor. So that's not a bad answer, but we want to practice getting rid of negative exponents and fractional exponents at the end. So let's do that. 20 is 20. How can we rewrite a to the 5 halves? Square root of a to the 5th. Good. Times b becomes square root of b to the 17th, right? So that's also both a fine and dandy answer. But because they're both square roots, you had this little property back in the day, right? The square root of a times b is equal to, well, we can work straight down without that. It's the square root of a times the square root of b, because it's really the whole thing to the 1/2 power. So it works the other way as well. So because they're both square roots, we can actually combine them under the same radical and call it square root of a to the 5th b to the 17th. So why would that be considered more simplified than the line above? Less things, fewer things, right? Remember, if you can enumerate them, it's fewer. If it's a math quantity, it's less, right? So we have fewer things, namely one less what? Or one fewer radical, right? One fewer radicals. So there you go, purdy, purdy, purdy. Don't you think so, Mr. Falcone?
Very, very nice.
See, he can appreciate the austere beauty of a mathematical expression. Yeah. And so can y'all. All right, any comments or questions on that one? Okay, letter B. Ooh, U's and V's instead of X's and Y's. Is that going to make a difference? No. No. Okay, what should be the first step in simplifying? What have we been doing? I spy a fractional exponent, okay, because we have a radical. We have the square root of blob, right? Square root of blob. So we're going to go ahead and write that entire blob, and notice how I did that. Parentheses with some space in between there to the what power? Good. Don't say squared. 1/2 power. Okay, so that takes care of the radical. Now, there's no reason why you just simply rewrite everything from above down below. You actually inside have a numerator and denominator, and you have 4 factor groups. So build your shelf, as we already mentioned, and go ahead on this line and see if you can't do anything on the inside to make the problem a little bit easier. Okay, so look at the first factor group, 2u to the 5th, the quantity. That becomes what? Can we simplify it? 2u times 2u times 2u times 2u times 2u. Yeah, it's 2 to the 5th, u to the 5th, right? It's the same little rule that we've been using. They both have implied exponents of 1, so if you want to write it as 2 to the 5th, that's fine. And then u to the 5th. And we got rid of a set of parentheses. Yay. Okay, so now, here's what you could do. If you notice, there's no other parentheses on the inside, but we have like factors. See that? And so we have a couple of options. You can either slide the v to the -2th to the bottom, as y'all were kind of doing the other day, or we can combine those using the rule of exponents. It says we do what when we're dividing? Subtract. What would y'all be more comfortable doing? If you subtract, you get rid of them right away. If you bring the v to the -2th to the bottom, you're going to have v's in the bottom. So let's go ahead and use the rule, okay? Now remember, when you use the rule, it ends up in the numerator. So it would be -2 minus 3. What is -2 minus 3? -5, okay? So that ends up in the top. Now notice, ultimately, it's going to go to the bottom. But right now, it's in the top. Okay, so in the bottom, we then also have a 3, which can't combine with anything. And we have a u to the -1st. So notice I did not try to combine this u to the -1st with that new u. Not yet. Okay, that's where the next line is. So before we move on, is that line equivalent to the one above it? Because if we're missing anything, you're going to lose a check. Has to be completely equivalent. Is it? No. Yes. Okay. See you later, Mr. Falcone. Thanks for stopping by. Okay, so now we go on to the next line. And you can either have an outside-in approach or an inside-out approach. So right now, if you want to distribute the 1/2 exponent to everything, feel free. But it's probably easier if you work from the inside out, right? Simplify early and often. So we have these u's inside that we can combine. So let's go ahead and do that. All right, so I'll still keep all this to the 1/2 power. And then let's simplify as we go. 2 to the 5th, is that 10? No, it's 2 times 2 times 2 times 2 times 2, which is 32. That's one that we're going to use enough. You should probably just kind of know that. 2 to the 5th is 32. The 3 is going to still be a 3. So this is going to be now u to the what? Good. 6. There's a negative down below, and sometimes psychologically, if you're not careful, you can mess up. You could say, oh, I know I got to subtract, but look, there's already a negative. So 5 minus 1 is 4. Nope. It's 5 minus negative 1, which becomes 5 plus 1, or 6. Good. And now the only thing that's left unaccounted for is the v, and it's the only one left, and it's a negative exponent. So here's where you might say, hey, guess what I want to do with that now? Slide it to the bottom, which we can because it's multiplied. It's a factor, and we can change its sign now to positive 5. Okay, and there's extra space in there, but that's fine. Is that equivalent to the line above? Yeah, is it looking better? Yep. Okay, so now on the inside we have one representative number, 32/3 if you will. They're co-prime, and we have one u and one v. So now it's time, if we haven't already, to do something with the 1/2. So we distribute it. Okay. So when I do that, again, I'm going to help myself here. I'm going to put little ones there. If I can see all the exponents and all the factors, I'm less likely to make a careless mistake. So we're going to get 32 to the 1/2 power. U to the what? What's 6 times a half? 3. Good. All over 3 to the 1/2 power, and v to the what? 5 times 1/2. You just multiply straight across. So 5 2ths, right? Or 5 halves. 5 over 1 times 1 over 2 is 5 over 2. And I can get rid of the parentheses there because I got the 1/2 distributed. Okay? I'm going to rewrite that. So now it's looking really good, right? No more parentheses. All the walls are torn down. It's still equivalent. And now we just try to combine like factors. Well, the only thing we have left are the numbers. Okay? 32 to the 1/2. Is that equal to 16? Because that would make a really great answer choice on a multiple choice question on the test on Thursday. To get this far, then to have the wheels come off would be a shame, wouldn't it? Because that's not 32 times a half, that's 32 to the 1/2, which come over here, they're off to the side, your bench work. That's the same as the square root of 32, right? Yeah. Now, is 32 a perfect square? No. But remember, we can simplify radicals if 32 has a factor that is a perfect square. Does it? It's 16 times 2, right? And 16 is a perfect square. So if you want to kind of show more steps, that's the same as the square root of 16 times the square root of 2, of course, which is 4 square root of 2. So notice I did that work off to the side because I knew it was going to require a lot of work. I was thinking about it. And if you did it in the context of the problem, you'd have to bring everything down every line. So this is my bench work. So in the numerator, I'm going to replace 32 to the 1/2 with 4 square root of 2. And in the bottom 3 to the 1/2, that's just the square root of 3. And now I got u cubed. And the last thing I'll do is rewrite v to the 5/2 as a radical. Is it the 5th root of v squared or the square root of v to the 5th? Square root of v to the 5th, yeah. Okay. So this is not a bad final answer. But as we just saw in the previous example, in the bottom, they're both square roots. And there's the square root of 2, so we can put them under the same one. So 4 square root of 2 u cubed, and if we want, we could say it's all over the square root of 3 v to the 5th. You could technically put the 2 in there, but because it's in the numerator, we'll leave it like that. So there you go. That's a good answer right there. All right. So notice we didn't do that problem in one line, right? Did Michelangelo create his masterpiece David with one swing of his hammer? No, chipped away at it, right? He just saw a slab of marble, and he just simply and slowly chipped away all the parts of that block of marble that were not David. Okay? That's what we did. Inch by inch, it's a cinch. Comments, questions? Quips, concerns? Okay. So that brings us to the culminating event of this lesson. This guy. Oof. 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 Okay, take a minute and chew on it a little bit and see if you can at least figure out what a good first strategy would be, and then we'll do it together. Okay. What would you do first? If you saw this on a free response on Thursday's test, which very possibly could be, what would you do? That's like half of your test grade. You just chip away all the parts that are not the right answer. All right, if you think you're on your way, feel free. There's going to be a lot of different sequences that someone can take in the process of simplifying this one. But what you probably most noticeably notice are the radicals, right? So at least you know you're going to have to write those radicals as fractional exponents. Now, here is the first time we've seen an entire fraction quantity raised to a negative exponent. There's two ways to handle that. If you work from the outside in, if you distributed the negative 3 exponent to every factor, it would change all of their signs. And then to make those signs positive, you would take them to the other side. So here's another option that you have. If you ever have a single fraction raised to a negative exponent, your first step could be, if you don't like negative numbers, is to flip the fraction. Okay? So put the numerator in the denominator and the denominator in the numerator. You flip the fraction and change the sign of the exponent. Okay? Now, you don't have to do that. You could distribute the negative 3 and deal with the negatives later. Okay, so I'm going to flip it. Now, there's no sense in just writing that version of it because that's going to take a whole other line of writing. So let's focus on the original denominator. Okay? The original denominator now, because I flipped it, is going to be in the numerator. And as I said last time, you can either say it's that entire blobby quantity to the 1/4 power and then distribute the 1/4, or try to do it in a single step. If this whole thing is to the 1/4 power and then I distribute it, it'll be y to the what power? 3/4, right? So instead of saying it's like this, I'll do this off to the side. Instead of saying y cubed to the 1/4, we'll just call it y to the 3/4. But I'm going to write it in the numerator instead of the denominator, right? Because I've flipped it. And then the next one would be x to the 1/2 to the 1/4 power. So what's 1/2 times 1/4? Remember, 1/2 times 1/4, you just multiply straight across when you're multiplying. It's 1/8. Yeah. Okay, so I did two things in one there, and again, I would encourage you to try to do that. But if you can't, then do it as two separate steps, or do it off to the side. When you multiply fractions, you do not need a common denominator. You just multiply straight across. Okay, so that's the old denominator now in the numerator. And now the old numerator I'm going to put in the denominator. So there's a 2 down there. And notice I'm going to do something else up there. I have two factors of x, which I can combine by doing what with their exponents? Adding, because this is multiplication, becomes addition. What is 3 plus 1/2? How many halves? Yeah, it's 6 halves plus 1/2, which is 7 halves. I'm going to call that x to the 7 halves. Because again, it's 3 plus 1/2. You just say, oh, 1/2, so 3 times 2 is 6. 6 plus 1 is 7, so I get 7 halves. And then I get y to the negative second. All right, so notice I'm only combining things. You don't change any of the signs when you flip it, right? Because that outside negative takes care of that. So it's still y to the negative second in the bottom. So you can flip the fraction and then try to consolidate. Okay, so that's the first factor times, we'll do the same thing here. I have 3 factors under a cube root, so every one of the factors gets the factor in the exponent of what? The cube root is the same as to the what power? 1/3. So I get 4 to the 1/3 times x to the 1/3 times y to the, what's -6 times 1/3? -6/3, which is -2, right? It's like -6 divided by 3. Okay? So all I did is distribute the 1/3 factor to each factor exponent. And I got rid of the parentheses. Okay, so that was a good first step. Everything is still equivalent. Okay, so now the second factor looks good. And again, you can either distribute the 3 now, or you can kind of work from the inside out. You've got x's and y. So let's go ahead and kind of keep that as a strategy. Let's continue to work from the inside out. So I'm going to leave the 3 there. 4 to the 1/3, I'm going to leave it like that for now. X to the 1/3 and y to the -2. Okay, so let's go ahead and build a shelf. Inside the parentheses, I already have the 3 out there. The 2 stays there. Let's do the x's first. So in the top, I have x to the 1/8 divided by x to the 7/2. So what do I do with the exponents? Subtract. So 1/8 minus 7/2. Off to the side here. 1/8 minus 7/2. You don't want to do the crisscross applesauce here because they're not co-prime. The LCM is 8. So if you want, just multiply that by 4 over 4, and you end up with 1 minus 28, right? What is 1 minus 28? -27 over 8. That is the new exponent on your x. -27 divided by 8. Wow. How many of y'all knew when y'all got out of bed this morning that you were going to meet -27/8? I sure didn't. But there he is. And then we'll do the y's. Y, again, the rule always puts the answer in the numerator. 3/4 minus -2. 3/4 minus -2. Let's go over here and do it. 3/4 minus -2 becomes really 3/4 plus 2. Well, 2 is how many fourths? Multiply by 4 over 4, you get 8/4, right? So what's 3 plus 8? 11/4. So that becomes 11/4. Okay, so now we have one representative factor inside the blob cube, and then we've got one of each type on the other factor there. And then you can put a dot there if you want. Okay, so now it's time, if you haven't already, to account for that 3. We need to distribute it to all the factor groups on the inside. So multiply, multiply, and then on that 2, I'm going to put a little 1. I'm going to put a little 1, and here we go. If you multiply, 3/8 doesn't simplify, so drop in parentheses. It's x to the, what's 27 times 3? It's 3 to the 4th. It's going to be 81, right? And if you need to do that off to the side, 27 times 3, it's 81, but it's negative. So it's -81/8. Hot dog. And then I got y to the 11/4 times 3. Just multiply straight across. Because 3/4 doesn't simplify, you get 33/4. And in the bottom, what do you get? You get 6 or something else? 8, because it's 2 cubed. It's 2 cubed. All right, so I'm just going to leave it like that, 2 cubed. Okay, so we got rid of the parentheses there. And now over here, I'm going to go ahead and rewrite the next factor to match the second one or the first one with a numerator and denominator. So 4 to the 1/3. Now notice here we've seen this before. I have a 4 and a 2. They are not the same base, but can I write them in terms of one or the other? Yeah. So in this case, I'm going to call 4 2 squared so that I can combine it with the 2 cubed down there. So that's going to be 2 squared to the 2/3 or 2 to the what power? If you have 2 squared to the 1/3, that becomes 2 to the 2/3. See that? So again, that's what you want to try to start doing in your head. 4 is 2 squared, so to the 1/3 is 2 to the 2/3. And then I have x to the 1/3. And then the last thing I'll do if you want, since it's y to the -2nd, you have the option of bringing the 2 down if you want and making it positive. Entirely up to you. Okay, so now that we've got each factor simplified completely, now it's time to start combining across. All right? So let's do that. one final answer here before we clean it up. Let's look at the numbers first. I have 2 to the 2/3 divided by 2 cubed. That's going to be 2 to the what? 2/3 minus 3. So off to the side here, 2/3 minus 3. 3 is how many thirds? If you multiply by 3 over 3, you get 9, right? So again, that's something you can do in your head. A whole number multiplied by the denominator. So you get 9. So what's 2 minus 9? -7. So you end up with -7/3. That's the new exponent on the 2. -7/3. Okay, so we're done with the numbers. Now here's something else you could do to help you keep track of inventory. When you're done with something, you can kind of draw maybe a faint line with your pencil through it, or choose a different color and notability so that you can still see what was underneath, but you know it's accounted for. Because really, it's just being a careful record keeper at this point. Okay, let's go with the x's now. So in the top, I have x to the something times x to the something, so I add their exponent. So again, come over to the side, that's -81/8 plus 1/3. Oh boy, 8 and 3 are co-prime. So let's do our little crisscross applesauce thing here. 81 times 3, that's -243, plus 8 times 1 is 8, all over the product 24. So again, I'm doing it off to the side not only to show you, but to tell you that if you need to do this, because you still can't do it in your head, that's fine. Just do it off to the side. And now -243/8, if you add 8 to -243, you get -235/24. And if you've been simplifying your fractions as you go, these two should be co-prime at the end. Okay? So there you go. You may have read about this number or seen them on celebrity shows, but maybe never in your life did you ever think you would meet -235/24 in person. And here he is today. What a number. That is the new exponent on the x. Fantastic. Sweet. So the good news is we're almost done. The bad news is we're almost done. Y to the 33/4 divided by y squared. What do we do with the 33/4 and the 2? Subtract. So again, off to the side. 33/4 minus 2 over 1. Again, it's a whole number. So just multiply the whole number by a denominator over denominator. So that's really 33 minus 8. What is 33 minus 8? 25/4. And that's the exponent on the y. Now notice, because we used the rule of exponents by subtracting, everything ended up in the numerator, which means it's really over 1. So you can erase that if you wanted. But I'm going to leave it, because our last step, now that we have one number factor, one x factor, one y factor, is to A, get rid of all the negative exponents, and B, get rid of all the fractional exponents. And we're going to try and do that in one step, okay? So build a shelf. The 2 to the -7/3 goes to the bottom, and it becomes 2 to the +7/3 in the bottom. So it becomes the what root of 2? Third, right? The cube root of 2 to the 7th. Now, 2 to the 7th, you can actually evaluate. If 2 to the 5th is 32, we've already seen that. Just multiply by 2 a couple more times. 32 times 2 is 64. 128. Yeah. So that's probably a better answer for your number. Okay, the cube root of 128 in the bottom. The x goes back to the bottom now because it's negative, and so that makes it times the 24th root of x to the 235th. Ain't that something? Whenever you're writing your root index, make sure, again, you write it in the little radical v there and not out front, because then it looks like it's a multiplier and not a root index. And then the y, being a positive exponent, stays in the top and just becomes the 4th root of y to the 25th. And that right there is a fine answer. All right, so might you see anything that grotesque on the test? Maybe. If so, on a free response, you would get partial credit for intermediate steps, okay? And if you make a wrong step and you continue correctly after that, you can still recover, all right? But yeah, the only thing that made this one more fun than the others is just because it was like 3 problems in one, or 4 problems in one. But remember, you just work on little pieces, little bit at a time, remove barriers, and ultimately combine things, okay? So So it's just multiple steps. And of course the fractions makes it kind of interesting too, right? Because y'all probably have never had to work with fractions like this without a calculator before, but this is now. That was then, right? All right, any comments or questions on that one? Inch by inch, it's a cinch. Any shame in doing this bench work off to the side? Not at all. But where do you do that work? Off to the side. Yeah, again, notice that every line that I've written here in the flow of the problem is still equivalent to everything above and below. So when I do the work up here, again, I'm modeling to you how you should be giving it back to me on any kind of assessment. That's the language of mathematics. Okay, so if there's no other questions, go ahead and download 1.3. 1.3.